So, electric vehicles that charge in minutes, solar farms powering entire cities, 5G network connecting billions of devices. None of this futuristic tech is possible without silicon carbide. But right now, the industry faces challenges. Over 80% of silicon carbide chips are made on 6-inch wafers, and the demand is skyrocketing. Is transitioning to 8-inch wafer a solution? Today we'll explore why this shift isn't just an upgrade, it's a revolution that will define the future of the clean energy and electric mobility. So for those who don't know, my name is Stanley. I'm multilingual Danish-born Chinese with a degree in Master of Science Engineering. I've been studying and working abroad for many years. I've been part of the Nobel Prize laureate Professor Akasaki's research group, conducting work on third-generation semiconductor. Also, I've worked on billion-dollar projects with China, and this is what I've learned. So this is what powers our electric vehicles today. But this right here is an 8-inch. So you see the size difference? The 8-inch wafer is what makes our EVs or contributes to a cheaper EV. The shift to 8-inch isn't just technical, it's economic survival. And here why it matters. 8-inch silicon carbide wafer with 78% more area. This isn't just about size, it's about transformative efficiency. An 8-inch wafer provides over 2 times more chips than a 6-inch wafer. This is because smaller size wafers suffer from die size, edge losses, and yield rates, and geometric limitations. So you can imagine jumping from roughly 200 chips to over 500 chips per wafer. That scale slashes cost by 20 to 30% per chip. And more critically, 8-inch lines can leverage existing silicon semiconductor factories. That means that you can retool existing mature silicon fabs for silicon carbide, which is far cheaper than building new plants. And this is also exactly why companies like SICC, TangerBlue, STM, and onsemi are already ramping up their 8-inch silicon carbide. And for automakers, this means cheaper, more efficient power electronics, accelerating the EV revolution. Now, scaling up isn't simple. Silicon carbide is extremely hard to manufacture. Growing perfect 8-inch silicon carbide crystals requires extreme precision. Even tiny defects can ruin the entire performance of the EV. So what market impact does it have? And what does this mean for the future, for the world? Well, by 2027, 8-inch wafers will dominate the silicon carbide production. Now pivot to the European Green Deal, that moonshot for climate neutrality by 2050. Can they pull it off? Honestly, I don't know, but they are trying. And to build anything that big, you need the right bricks. This right here, silicon carbide, it's one of those bricks. Not flashy, but without it, those efficient EVs, those solar farms, the whole green future, it's just poetry. Silicon carbide makes it real. So what does that translate into? First, the EV wins. Power electronics becomes very affordable, making electric cars cheaper for everyone. Look at the U7 Xiaomi car, 250,000 RMB for one SUV. Second, renewable get faster and more efficient. Think highly voltage solar inverters and grid infrastructures. And third, it secures supply chain, reducing reliance on strained 6-inch production. For investors, this is a massive opportunity. The silicon carbide market will top billions by 2030, and leaders in 8-inch tech will shape the future energy. So at the end of the day, the move to 8-inch silicon carbide isn't optional, it's essential. It's the key to affordable EVs, robust clean energy, and a sustainable future. Now, whether you're an engineer pushing the boundaries, an investor tracking the next big opportunity, or a policymaker enabling the energy transition, this revolution matters. The 8-inch silicon carbide era is here. It's bigger, it's smarter, and it's more powerful than ever before. Now let's address the elephant in the room. A few months ago in the Shanghai Semicon, we saw the 12-inch silicon carbide wafer. Several Chinese companies, including Tongguang, SICC, 𝗙𝗙𝗘𝗚, and other companies, were demonstrating their 12-inch silicon carbide samples. But remember, those were not for electric vehicles. Because today's 12-inch technology can't meet the zero defect demands for EV power electronics. A single flaw in the EV inverter could cause system failure, but that is not the same for VR headsets or glasses for that instance. Although the 12-inch silicon carbide wafer tries to target the AR, VR, virtual reality, augmented reality application, this still remains a niche market. Billions are poured into the virtual reality application. EV still remains the biggest driver for the silicon carbide demand. Let us also be real. Given the price and maturity of 12-inch silicon carbide, I think it's going to boost the VR space. However, until then, the 8-inch revolution is already here, delivering real-world impact today. Let's return to our opening question. Is transitioning to 8-inch the solution? How does larger silicon carbide enable faster, cheaper, and more accessible electric mobility? The 8-inch wafer answers it decisively. By fitting more power into every inch, cutting cost at scale, and turning cutting-edge performance into mainstream reality. As for the future, the road to 12-inch starts in the VR labs. But today, right now, the 8-inch revolution is powering our electric decade, one wafer at a time.